All right, folks, for the last few days, we have been working on using the distributive property to simplify expressions. Today, we are going to talk about another skill that you will need in order to simplify expressions. Today, we are going to review recognizing like terms. So for today, we will be recognizing these like terms, and then starting tomorrow, you will actually be combining like terms. So two really, really important skills for Algebra 1. All right, so what I'm going to do here is I'm going to write a problem on the board. 7x squared plus 2x minus 5 plus 3x minus 10x squared plus 4y minus 9. Now that's a good sized problem, okay? And I've given you this problem so that we have something to kind of talk about here. Now, we are going to be using this word quite a bit. Terms. Terms. Okay? And here's what I need for you to know about this word. You need to make sure you understand its definition. Terms are parts of a math problem that are connected by addition or subtraction. So terms are parts of a math problem that are connected by addition or subtraction. So on the board right now, we have a pretty lengthy math problem. Okay, if I wanted to know how many terms this math problem has, then what I would do is go through the problem and look for addition or subtraction signs because those are connecting my terms. So I'm going to highlight these. I see a plus sign here. I see subtraction here. I see adding here. Subtracting here, adding here, subtracting here. All right, so I've marked all my adding and subtracting signs in my problem. So now I can look at how many terms I have. So here is one term, 2, 3, 4, 5, 6, and 7. So this problem that I'm looking at, this particular example that I've written on the board, has a total of 7 terms. A total of 7 terms. So, here's what I think I'll do with this. I think that I will make myself a little chart here. Now, I want you, as I list these terms in my chart, to listen carefully to what I'm saying about them, okay? This 7x squared that I see up front is my very first term. So I'm going to write him in my chart. Now when I get to my next term, 2x, what I want you to do is take into account the sign that's in front of him. This is 7x squared, and then it says plus 2x. Plus 2x. So that 2x is being added. That makes him positive. So that is a positive 2x. The next thing I see is minus 5. Minus 5. So that 5 is being subtracted. That makes him a negative 5. then I see plus 3x. Plus 3x. He's being added, so that makes him a positive 3x. So I want you to notice what I'm doing. I'm looking at the sign directly in front of the term and using it to help me decide if that term is positive or negative. So continuing on, after plus 3x, then I have minus 10x squared. Minus 10x squared. He's being subtracted, so that makes him a negative 10x squared. After that, I have plus 4y. So that 4y is being added. That makes that 4y a positive. And then my last thing is a minus 9. Minus 9, that makes him a negative 9 because he is being subtracted. So if a term is being added, that makes it positive, and if a term is being subtracted, that makes it negative. So here's a list of all 7 terms that I see in my problem. Okay, now, each of these terms has 2 parts. Each of these terms has a coefficient and then a variable part. And we are going to refer to that variable part as being the term's last name. Now, coefficient is a word that I imagine you've heard before, but I'm going to review it anyway to make sure you remember what it means. The coefficient is the number in front of the variable. That big number that sits in front of the variable. So when I look at 7x squared, the coefficient here would be the 7. When I look at 2x, the 2 would be my coefficient. Now you'll notice on this next term there is no variable part. That's no big deal. The coefficient is still the number. So negative 5 would be my coefficient. For 3x, my coefficient would be the 3. For negative 10x squared, my coefficient would be the negative 10. For 4y, it would be the 4. And then for negative 9, it would be the negative 9. So the coefficient is that first number that you see. It's the big number in the problem. And it sits right in front of the variable. And if there is no variable, then that number just simply is the coefficient. Now, the variable part, that is the last name for your term. And it's all of it. So when I look at 7x squared, we've already said that 7 is the coefficient. The x squared part is the variable part. So the last name of that term is x squared. For 2x, we've already said that that 2 is the coefficient. So the variable part is x. So x would be the last name of that term. Now look at this negative 5. The negative 5 is the coefficient. There is no variable part. So this particular term has no last name. For 3x, 3 is the coefficient. The variable part is x, so the last name is x. For negative 10x squared, it would be x squared. For 4y, it would be y. And for negative 9, no variable part, so none. So terms are connected by addition or subtraction in math problems. And a term has a coefficient and a last name. The coefficient is the number in front of the variable, and the variable part is the last name. Now, let me show you a couple of other things here before we leave this behind. Let's say that I have 5x squared y. 5x squared y. Now, if I look at that expression, you'll notice there are no addition or subtraction signs. So what that means is, since there are no addition or subtraction signs, this is just one term. So it is possible to have just one term. And your problem only has one term if you don't see any plus or minus signs. So this is one term. For this particular term, your coefficients would be the 5, that number that we see sitting in front of the variables, and our last name, notice this time, has 2 variables in it. So all of this variable stuff over here is the last name of that term, so it would be x squared y. So we have a coefficient of 5 and x squared y as a last name. Let's suppose that I have xy. Now you'll notice again here, there are no plus or minus signs in that. So what that means is, this isn't connected to anything else. That makes him one term. Coefficient. When I go to look for the coefficient, it's supposed to be that number that sits in front of the variable. But when you look right here in front of the variable, there's nothing there. You need to remember that when that happens, you have an invisible 1 there. So your coefficient on this would be 1. So everything has a coefficient. If you can't see it, it means it is an invisible 1. And then for this particular term, the variable part would be the last name. So the last name for this term would be xy. So the coefficient is the number that sits in front of all of those variables. If he is missing, he is a 1. And the last name is the entire variable part of the problem. It doesn't matter how many variables are there or what kinds of exponents they have. All of it goes together to make the last name of the term. Now the reason that I am making a big deal about those last names, about the variable part, is that that is going to help us recognize like terms. Like terms in a problem are the terms with exactly the same last name. Like terms are the terms in a problem that have exactly the same last name. Now this word right here is really important. Exactly. That means they have to be identical. There can't be any differences in them at all. So terms with exactly the same last name. Now, let me do this with you for just a minute. Let me see if I can take you back to that first big problem that we did. There were 7 terms in this problem. Some of them are like terms, and some of them are not. So, when I look at these 7 terms, let's see if we can figure out which ones are like terms. Well, I'm going to start out with 7x squared. Now, what did we say his last name was? The last name is the variable part, so it's x squared. So even though the second term has the same letter, it has the x, he's just x. He's not x squared. So 2x would not be a like term. A like term for 7x squared would have to have an identical last name. So it would have to have x squared. So 2x won't work, negative 5 won't work, 3x won't work. But when I get here, negative 10x squared, that is an identical last name. So 7x squared, negative 10x squared are like terms. And they don't match anybody else in that list. All right, I'm going to change colors here. Let's go to 2x. Now again, think about what his last name is. His last name is x. It's just an x. So like terms for him would have to have that same last name. They would have to have just an x. So negative 5 wouldn't work because he doesn't have x. 3 would work because he has the identical last name. He has x. 4y wouldn't work because x and y aren't the same last name. And then negative 9 won't work because he doesn't have a variable. So 2x and 3x would also be like terms. Let's do negative 5. Now, what do we know about negative 5's last name? Well, what we know about negative 5's last name is he doesn't have one. So a like term for negative 5 is going to have that same characteristic. He's going to have no last name. So the term that matches negative 5 would be the negative 9. And then you'll notice that all that leaves us is this one lonely little term in our list, 4y. Nobody else is like him. He has a last name of y, and nobody else in this list did. So this is what we're attempting to learn how to do today. We're attempting to look at terms in a problem, which are the parts that are connected by addition or subtraction, and determine which ones are like terms. So I need you to understand coefficient and variable part, which are last name. The coefficient is the number that's in front. Remember, if he's missing, that means there's a 1 there. And then the variable part is all of the stuff that comes after that coefficient, all of the variables, all of the exponents. And to be like terms, they have to have an identical last name. Okay, so let's do this. I am going to write several terms on the board, and then we will go through and figure out which ones are like. All right, sorry about that interruption. I'll pick up here where I left off. Just making up a bunch of terms here. Okay, so here is an entire pile of terms. When I look through them, I'll see things like x squared y. I see over here xy squared. So what we're going to do is go through here and identify which terms on the board are like terms. All right, so I'm going to start up here in the left-hand corner with my very first term, 5x squared y, and I want you to look at him. That has a coefficient of 5 and a last name of x squared y. So the last name is what I'm interested in, x squared y. So any other term on the board that's going to be his like term needs to have that same last name of x squared y. So I'm looking for x squared y. This just has an x, so that's not a match. This has x y squared. Same letters, x and y, but notice this is x squared y. This is xy squared. It's not identical, so not a like term. This has no last name. The 9 has no last name. 3y, not a match. 4x to the third, not a match. 6xy squared. Now again, that's close. X squared y, xy squared. The exponent's in the wrong place. Negative 15x, 5x to the third. X, which remember would be 1x, negative 17x squared y, 5x squared y, negative 17x squared y. This has the same last name. They match. So notice the coefficient doesn't make things like terms. It's only that last name. X to the third, no last name, x squared, no last name, xy. So right now, those two are like terms. They have an identical last name of x squared y. All right, so now I'll move on to another color. And I'll just go ahead and come down here and pick up my next term, negative 6x. So this last name is very simple. It's just an x. So I'm going to look through these terms and identify all of the other terms that have just x as their last name. So this is a no, this is a no, this is a no, no, no. Here's one, negative 15x. That would be a no. This is a yes, because this would be 1x, 8x to the third, 95, 2x squared, negative 13, 15xy. So the three that I just marked in blue, all like terms because they have a last name of x. Now, we have 4xy squared, so I'm looking for an x and a y squared. No, no, no. This would be a yes. He has an x and a y squared. So the variable part has to be identical. No, 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 no. So those two are like terms. Next up, we've got a 9. Whoops, it's not a highlighter. Let's try that again. We have a 9. Now notice that 9 has no last name at all. So like terms for him will have to have no last name. So negative 13 has no last name, and 95 has no last name. So those three would be like terms. Next up, we have 3y. 3y, last name of y. Does anybody else have a last name of just y? I don't see anybody, so he is all alone. He does not have a like term. Let's see. Let's go to this next. 4x to the third. 4x to the third. Last name is x to the third power. Does anybody else have that? Well, yeah. 5x to the third power has that exact same last name, and 8x to the third power has that exact same last name. And you'll notice with that I only have two terms left that I haven't dealt with. 2x squared, which has a last name of x squared. Nobody else is like him, so he's alone. And then we finish off with 15xy. That's not a very pretty color, but his last name is xy. So the like terms don't depend on their coefficients to be the same. What they depend upon is their last names to be the same, and we mean identical. They have to match perfectly. Now, before I leave you with this, I want to show you what your assignment for today will look like and make sure that you see how to complete it. So here is what today's assignment will look like. It's a Google Slides presentation, and these are the directions. It says on the next slide, identify the like terms by coloring the rectangles using the same color. You will color the rectangles by clicking and dragging the colored rectangles into the boxes in the grid. Make sure all like terms are the same color. So when you come over here, you'll see this grid with terms in it, kind of like what I just did on the board. And you've got all of these colored rectangles over here to use to mark your like terms. So what I would suggest you do is you start in this top corner. So I would pick a green rectangle and put it around negative 3x squared. Now, his last name is x squared. So now what I'll do is I'll go through these other terms and look for anybody else who has that same last name. So right here is somebody. There is a negative 1x squared. So I would grab another green rectangle and put it around him. And then I would continue going through here and checking my terms. Here's another one, 10x squared. So I'll bring this over and put that around him. Then continue on Right here is another x squared over 3. So you'll continue to do that. You'll go through the whole chart until you have marked all of your x squares. And then what you'll do is switch colors. So we'll bring negative 10, we'll bring the red square over here to this next one, negative 10x squared y. So now I'm looking for x squared y's. And I'll go through my chart. Here's another x squared y way over here, so I'll get the same color and put around him. So you want to mark your like terms by using the same color rectangles. So that's all you're going to be doing today. And then tomorrow we will talk about what you're going to do with these like terms. If you have any questions, this is so important that you understand this. So if you have any questions, please, please, please email me today. Let me know. We can set up a Zoom call or whatever we have to do to get you straightened out. So you'll find this assignment that I'm showing you here in Schoology in the folder. Get that done and submit it. And let me know if there are questions. Thanks a bunch.